work from all of you, and we hope to see more winners in our next round.
By wearing those colors. The current points are staff with 8 points, grade 9s with 87 points, 12s at 153 points, 10s at 162 points, and grade 11s in the lead with 188 points. Remember that you can only wear your assigned color for free or uniform. As a reminder, grade 10s wear black, grade 10s wear gray, grade 11s are blue, and grade 12s wear green, and the staff can wear spirit wear. Good luck, McLuhan. Today is the last day of basketball sports in intramurals during day 2 lunch seat. See you all there. All CPR students, please report to the library. Thank you. And to give a birthday shout out to Miss Fabiano. Happy birthday. Thank you and have a wonderful Wednesday, McLuhan.
One, two, three, four, 5. Not here. 2, yeah. A and Lewis are at CPR training. Okay.
Ansel's here.
Ansel's here somewhere? Oh.
Everyone's late.
Any questions? Okay. Let's do 2.4. 2.5. 2.5. Derivatives of quotients. So we are nearing the end of chapter 2. Oh, there he is. Good morning.
Slippery day.
Slippery day, yeah. Yeah, so we'll look at doing the chapter 2 test next week. I think I had it on the calendar for Monday. I don't think that will change because today is Wednesday, tomorrow's Thursday. We can do 2.6, and then Friday we could just do a review. Yeah.
Me, John, and Carell aren't going to be here on Monday.
Oh.
You don't think that's going to change?
What's that? Why? What's the reason?
There's like a
Phoenix School outreach workshop.
Oh, okay. Let me just see that calendar next week. No CPR training?
Oh, no.
No? Okay.
So you can elaborate?
He's just not going.
No, I'm just not feeling it.
He is. Yeah, but even if he rushes, you're still technically allowed to take the CPR.
Let's see. Well, if 3 of you are away on Monday, then maybe I could move the test to Tuesday. And then I'll just teach the next chapter on Monday. Yeah, I'll probably record the lesson, so if 3 of you are away, then we'll have it. Okay, let's do. Let me just update my attendance. We're just missing Carell and A is also on the CPR. Okay. Samuel is no longer in our class. He's not on the list. He's been removed. All right, 2.5. Another rule to add to our toolkit of derivatives. I'm going to record this. If I can, I don't know.
So make sure you have audio.
Yeah, I've made sure I have audio at this time. Okay, it's recording. There we go. I can make this screen bigger. All right, derivatives of quotients. Okay, so we're looking at the rational function this time. When f of x is defined to be p of x over q of x. So you have a function on the top and a function on the bottom. P of x and q of x are polynomials. Okay, and the usual restriction still applies. The denominator cannot be 0, so your polynomial at the bottom cannot be equal to 0. So we're going to develop a rule called the quotient rule to find the derivative of this quotient of functions. So I'm going to start with kind of redefining f of x so that we can put it into a form that we can find the derivative of. And that form is going to look like this. F of x equals p of x. And because we know division can be rewritten as the multiplication of its reciprocal, I can take q of x and write it as q of x to the power of negative 1. So kind of like taking the reverse reciprocal. Okay. So I want to be clear that that negative 1 is an exponent. It is not your inverse function. Okay, this is an exponent. Let's write that. And writing it in this form now allows me to use product rule, right? So we are familiar with the product rule. So writing it this way means we can use the product rule to help me find this derivative. Okay? And so the product rule states that if I take the derivative of f of x, I'll have f prime of x. And the derivative would be, if you remember product rule, derivative of the first function. So I'll be writing this as p prime x times the second function, q of x to the power of negative 1. And then we're going to put a plus, and then we will rewrite the first function, p of x, multiplied by the derivative of the second function. Okay, so think, okay, what's the derivative of q of x to the power of negative 1? And that derivative would be requiring us to use the chain rule. So q of x would be considered the inside function. Something to the power of negative 1 is the outside function. So if I apply the chain rule, I'm going to bring the negative 1 to the front. So negative 1 times the inside function, q of x, reduce the exponent by 1. Okay, that's not going to become a 0. It's negative 1 minus 1, which is negative 2. And then you multiply by the derivative of the inside. The derivative of the inside function would just be q prime of x. Okay, so far? So that's all product rule. And maybe I'll make a note here that this is the chain rule applied to q of x to the power of negative 1.
Good morning. Can all grade 9 classes please come to the cafeteria? All grade 9 classes please come to the cafeteria and sit as close to the front as possible. Thank you.
I don't know if I can edit that out of the video, but we will see. Okay, so f prime x equals. Now I'm going to kind of change this to make it a little bit more user-friendly. I think what I'm going to do is bring the q of x back down to the denominator. So here in the first part, I'll write p prime x over q of x plus, or sorry, not plus, it's going to be minus, because I'll just say the minus 1 is minus. Okay, and then we'll have p of x times q prime of x, and the negative exponent will now go down to the denominator as q of x. I'll put that in square brackets and say that's squared. Okay, and so now it might be nice to have one term instead of two terms. So let's find a common denominator by taking the first term and multiplying the top and bottom by q of x. So q of x on top over q of x on the bottom. So that on my next line, f prime of x is then now equal to my denominator, which will be, in the bottom will be q of x, all of that squared. And my numerator will be p prime x times q of x minus p of x times q prime x. Okay. And so there we have now a formula for the derivative. And this is called the quotient rule. So the derivative in terms of p of x, q of x, and each of their derivatives, p prime and q prime. Okay? So you can use this rule whenever f of x is equal to p of x over q of x. Okay, the quotient of derivatives, or derivatives of quotients. Okay, now yeah, the rule has to be memorized. AP exam has to be memorized. You will not get any of these derivative formulas at all on the AP exam. Okay, and it's usually my practice in the regular calculus even to just require students to memorize the formula. Okay. Okay, and again, like before, other derivations, I'm not going to require you to memorize the derivation or ever test you on deriving the formula. It's just here's the formula, let's use it. But I'm showing you where one possible way where it could come from. Okay. All right, so let's look at into some examples of rational functions like this one here. Given 2x minus 3 over x squared minus 4x, right? This is a rational function in the form of p of x over q of x. And I guess what's not listed here explicitly is that p of x over q of x is f of x. And so find the derivative of f prime x. Okay. Now the way you choose to do this, you can go directly to the formula and plug everything in, find your derivatives of p prime and q prime along the way as well. Okay. Or you can list out everything. P of x is this, q of x is this, p prime is this, q prime is this. But I'll go directly to the formula as my approach. So f prime x equals, starting with, and again, as you do this, you might have to refer to the formula, but you kind of look at what might be familiar. Like the top very much looks like product rule, but instead of a plus, there's a minus. Okay, and then the order of the p's and the q's might be a little bit different. And then the denominator, you just have to remember, okay, it's q, it's the second function. It's the denominator squared, right? So the denominator part might be easy to remember. The numerator part might take a little bit of practice getting used to. Okay, so I'll start with the first part, the p prime. We need the first, the numerator, the derivative of the numerator. So 2x minus 3, its derivative is just the derivative of 2x, which is 2. So that's p prime. As I go, I'm just going to write this above, p prime of x. And then the second part is q of x, so x squared minus 4x. And then it's a minus sign, not a plus. It's a minus sign. Okay. And then we look at the second part of my derivative. I need p of x, which will just be 2x minus 3 times q prime. And the derivative of the denominator will be the derivative of x squared, which is 2x, minus the derivative of 4x, which is minus 4. And that's q prime. All divided by the denominator of the function squared. So x squared minus 4x squared. So put that in brackets and square it. Okay, and then typically what we do is we do simplify. We expand and simplify the numerator. Okay, so if you expand and simplify the numerator and work that out, we will have minus 2x squared plus 6x minus 12. But we keep the denominator as x squared minus 4x squared. So expand and simplify the numerator. Okay. Now it might be possible that you might encounter a question where you can factor the numerator and then cancel a factor from the numerator with one from the denominator, and that might be a thing. Otherwise, it's usually, we usually keep the denominator as is, because if maybe we're looking for vertical asymptotes, or where's the denominator equal to 0, it's just easier to solve it having a factored form already. And maybe if you are looking for zeros of the derivative, it might be useful to have the factored form of the numerator if it's possible to find the factored form of the numerator. But as far as finding derivatives go, you can keep it to this step right here where you expand and simplify the numerator and then leave it like that. Okay. All right, let's look at another example. I'll put the answer for the U-try question at the end. Okay, so here, differentiate G. Okay, I'm using different lettering now because I want you to get used to the idea that we're going to take the derivative using the quotient rule. Let's not get pigeonholed into using P and Q all the time. Just looking at the approach that let's talk about in terms of numerator and denominator. So G prime of n, so we're even changing the variable as well, works like this. So you're going to be taking the derivative of the numerator. So before I take any derivatives, I'm just going to write here, okay, n cubed prime, I want to the derivative of the numerator, times the denominator 2n squared minus 1, take away the numerator, n cubed times the derivative of the denominator 2n squared minus 1 prime. Okay, and then you're going to be dividing by the denominator squared. Let me make these primes a little bit more curly so they're not kind of confused as ones. Okay. All right. So kind of as you do more of these problems, you get used to that idea. Okay, derivative of the numerator times denominator minus numerator times derivative of the denominator. And repeat that over and over and over and over again, it'll stick. Okay, whereas, if you try to memorize P's and Q's, then, well, maybe you might get confused because a P looks like a Q if you just flip it. Okay, so try and think of it in terms of numerator and denominator. So G prime of n, let's calculate the derivatives. N cubed would be 3n squared times 2n squared minus 1 minus n cubed times the derivative of 2n squared minus 1, which is be the derivative of 2n squared, which would be 4n. The minus 1 disappears. And then the denominator is 2n squared minus 1 squared. G prime n. Okay. And then the last bit would be, let's expand and simplify the numerator. So 3n squared times 2n squared is 6n squared, or n to the power 4, minus 3n squared. And then we have a minus 4n times n cubed is minus 4n to the power of 4, all over 2n squared minus 1 squared. And then we can just collect like terms once more in the numerator. So we have 2 terms instead of 3. So 6n to the power of 4 minus 4n to the power of 4 is 2n to the power of 4 minus 3n squared over 2n squared minus 1 squared. Okay, and then that's the derivative. I can leave it like that. Okay. You could go thinking like, well, I could factor out an n squared from the numerator if I wanted to, like if I wanted to factor it. Perhaps that could be useful if there was an n squared in the bottom to cancel out, right, and then simplify it even further. But if we're just applying the derivative and getting the derivative function, this is sufficient. Okay. Other questions that might come up, do I need to use the quotient rule? Could I have rewritten g of n and write it as n cubed times 2n squared minus 1 to the power of negative 1, and then use the product rule? You very well could, okay, and you would get the same answer. And it might be actually a good idea to, try this one later on to see if you do, okay? And so when you're taking a derivative in general, you're not pigeonholed to just using one rule, okay? But for the purposes of learning the quotient rule, you may get a test question that says use the quotient rule specifically. But in the future, as you're doing more calculus later on in university, it may be just a question is what's the derivative, and then you could apply whichever rule you like. Okay. All right, let's. So that's that. Any question on this example or the last one? Let's take another one. Something more complicated. I think this was the last one. Okay, last example. Differentiate y with respect to x. So I have a function. I'm going to write the function, this y, as in exponential form. So I'm going to get rid of that square root. So 2x minus 1 to the power of 5 divided by 7x plus 8 to the power of 1/2. Okay, so it might be a useful thing to do to write in exponential form as your first step. Okay. And differentiating with respect to x. So my next line, I could write y prime. I could write dy by dx to express this derivative. Okay, I'm not going to be very picky on that. So even if the variable was different, even if it was like n instead of x, and you still wrote y prime, I'll be okay with it. If it was time as a variable instead of x, and you still wrote y prime, that's fine too. Okay. I like dy by dx sometimes. If you had more than one variable, you should use dy by dx to specify which variable you're taking the derivative to with respect to. Okay, let's look at the derivative now. So the derivative using the quotient rule says, okay, I'm going to take the derivative of the numerator, right? The derivative of 2x minus 1 to the power of 5 will require the use of the chain rule. So you're going to be using the chain rule embedded within the quotient rule. Okay, so the derivative of the numerator is 5 times 2x minus 1 to the power of 4. Okay, so I'm not done yet, but okay, that's 5 times 2x minus 1. Reduce the exponent by 1. The 2x minus 1 is your inside function, so you also have to multiply by its derivative. And so the derivative of 2x minus 1 is just 2. Okay, so that's kind of like your p prime, right? This is just p prime. Then you have to multiply this by the denominator, 7x plus 8 to the power of 1/2. And that's your q. Okay, then you subtract by the numerator, 2x minus 1 to the power of 5. That's your p. And then you take the derivative of the denominator. Again, the chain rule. So the chain rule says bring the exponent 1 over 2 to the front. Multiply by your inside function, 7x plus 8. Reduce the exponent by 1. So 1/2 minus 1 is negative 1 over 2. And then you multiply by the derivative of the inside. So the derivative of 7x plus 8 is just 7. Derivative of 7x is just 7. The 8 goes away. Okay, and that's your q prime. And it looks fairly complicated, and that's fine. You'll end up getting lots of functions that look like this for its derivative. And then you divide by the derivative of, you divide by the denominator squared. So 7x plus 8 to the power of 1/2, and that's squared. Can I simplify the denominator? Yeah. Okay, so you can apply the power of a power rule. So power raised to a power exponential rule just means you multiply the exponents. So 1/2 times 2 just cancel out. Okay, so my next line, I'm going to try and simplify this a little bit. I'm going to write this as one big division line. So we know in the bottom we have 7x plus 8. So we can leave that as 7x plus 8. The numerator, however, looks a little bit different. Okay, 5 times 2, I'm going to combine the 5 here and the 2 here to make 10. I'm going to write the 2x minus 1 to the power of 4. And because we're kind of writing now like a final line, a final answer, it might be nice to make this a little bit better looking, organized, so to speak, by saying instead of 7x plus 8 to the power of 1/2, I'll just rewrite that as a square root once more. So the square root of 7x plus 8. And then a minus, where are my coefficients here? I have a 1/2 and I have a 7. So I can write that as 7 over 2. I'm introducing another fraction here in this term in the numerator. And I'll have a 2x minus 1 to the power of 5. And the 7x plus 8 to the power of negative 1/2 can be written as a positive exponent. In fact, going one step further, write it as a radical, square root of 7x plus 8. Yeah. Okay. At the end of doing all this, as long as you are, following our conventions, rewrite negative exponents as positive exponents in the numerator. Okay, and you can rewrite these as radicals again. So if it's possible to convert back to radical. We try and do that, okay? Can I clean this up any further? Maybe. Now you may get questions where you could. You may try to find a way to cancel with a 7x plus 8 if there was one. But you know what? It's just in terms of finding the derivative, like save yourself some time. Like you can stop there. Okay. Okay. All right. Questions?
Are you gonna put something like this on the test?
Maybe.
Oh, okay.
Yeah, maybe. I mean, for sure there will be a question where take the derivative using the quotient rule, and I will give you a rational function. How complex it is, I don't know yet. I haven't decided. Okay. I'm gonna. That's it. That's the end of the lesson. All right. I'm gonna stop the video. 23 minutes. Oh, awesome. Okay.